A Chinese saying, a picture is worse than 1,000 words. So a clear and a good quality picture can give the more valuable information. For insects, the problem is for the depth of the field. So if we need to get a clear and good quality photo, we need to use some other facility to help us. For our digitization of insect collection, we have to have this kind of facility. The first, we have a digital camera and the light equipment, also the monitor and the computer. For small bodies of insects, when we take photos, we often have the problems for the depth of the field. So we need to overcome this problem. We need using some facility to help us. When we digitize the insects, we have to using a program for overlapping all these photos. Before we capture the image, we must take great care with our specimens. So when we handling the procedure, you must keep a good habit. The most important thing we must keep in mind. Remember that without the labels, the specimen have no value. So treat them with as much care and never remove the label from more than one specimen at the same time. When taking pictures, the first thing we have to carefully position the insects. Focus and lightening is what we make good image. So it's worth taking time over this. We're using overlaying photo software called Helical Focus. So the image is taking software that completely solves the shallow depth of the field problem. This program that creates one complete focused image from several partial focused images by combining the focus area. After the overlapping, now we can see the right photos much more clear. Each pinned specimen of our collection is now attached with a barcode label on which the registration numbers, as barcode, of the specimen can be read either by machine or by naked eyes. So the first benefit is we can find where the specimen deposits. So this system can help us whether we want to find each record, browse record, and also add new records. It's most efficient when we search and query our collection. For example, we're using the numbers for query our specimens. Here we can find what species here. Okay, so now we can get all the information for this species if we type the numbers for this species. We also can use other like collection date, collector, or any other information we have. For example, we using the collection dates, and we using Yilan counties. Fushan and the Fushan, and we can see what species we have there. Okay, it takes time because in this area we have more collection layer, so it takes time. Yeah, we have lots of collection from Fushan areas. And in here we can see, in the right side, we can see the photo layer. It means this specimen we already have the digitized photo in combination with the species information, where, when, and who collects this specimen. So it's more convenient. We can get all the information for our collection. Okay, when we can query this is a total more than almost 50 individuals for this. Okay, we search again, we use in the location. Okay, so here we can show in this area what collection we have. We also can query by the dates, which day we collect in the field. If we choose from the 2001, then so we can know particular days or what seasons what species we have been collecting. So the database can give us information. We know where and when we collect each particular species. So we can arrange particular timing come for collect these species. And here if we see in the right side, we didn't see the photo for that species. It means that we did not do the digitize. So for like here, we only have a few of the species already have the digitized. For most of them, we still need to do the digitization. Okay, so from here we can query by the species name. If we know the particular species we want to looking for in our, like the Vespa. If the people, the taxonomy, we know what species we are looking for, we can type the species name. Okay, so here we can find how many species we have, and can query what information for this Vespa. For this species, we totally have 69 individuals in our collection, and all the collection information also with him. So we know who and when collect this species. And this system also can help us to do some statistic analysis. When we using the database, it's more easy and efficient, so we can get all the information for our collection. So the people, we don't need to, like the traditional way, we have to write down all the specimen information by each individual. Especially when we in combination with our barcode system, we can get more accuracy and more efficiency the information, and it's very reliable. It can reduce the typing errors.
Welcome to Taiwan Forestry Research Institute. I'm Yongtai Chao, Senior Scientist of Forest Protection Division and Curator of Forest Arthropod Collection of Taiwan at Taiwan Forestry Research Institute. Forest Arthropod Collection of Taiwan is one of the most important insect collection in Taiwan, and I'm going to introduce you our insect collection and let you know how we manage our collection, which represents a precious biodiversity heritage of Taiwan. Insects are, without question, the most successful group of organisms on the planet. Insect biodiversity accounts for a large proportion of all biodiversity on the planet, with over 1 million insect species described. Of the 18,000 described insects from Taiwan, most of them live in forest ecosystems. As you know, each specimen was collected in a specific time and space and is not replaceable. One may have spent a lot of effort to collect a specimen, and the specimen material and the relevant information should be kept in good condition for current and future users. Here I will use our management system of the Forest Arthropod collection of Taiwan to give you an idea how to manage the collection materials and information. The first insect specimen deposited in Taiwan Forestry Research Institute can be traced to early 19th century during the Japanese era. It's a beetle of the family Irritilidae collected by D.L.J. in August 1910. In fact, I do not know what D.L.J. really means. More specimens were collected by Chinese entomologists after World War II, when Taiwan was returned to the Republic of China. These specimens include extinct species such as Juvia large crow and other legally protected insects. I took over the entomological laboratory in 1993 when our previous entomologist retired. I consolidated all the specimens scattered around and put them all together in the penthouse of the building in 1993. And later in 1996, all these materials were moved to another building. 4 years later, these materials were again moved to a newly built forest conservation building. The planning and the building of the forest conservation building lasted almost 10 years and was formally opened in year 2000. This is a layout of Forest Arthropod collection of Taiwan in the 4th floor of the forest conservation building. You will see the whole space is separated into several big blocks, including a study room, a preparation room, and the 3 collection rooms. The first one I'm going to introduce is the study room. This is a rather small room down the corner of the 4th floor. Traditionally, scientists or taxonomists study the insect collection in the collection room, which I think is rather hazard to the scientists involved. So I designed a separate study room so that a microscope and other facilities can be put here, and the taxonomists or scientists can study their materials or check their materials, examine their materials without interfering the collection. Also, in this room, we can set up our photo facilities for our digital archive program, which will be introduced later. I also designed a preparation room so that the people who prepare the specimen will not interfere with the collection. This is our preparation room. It has ample space and enough light, and our colleagues can work happily here without interfering with the collection. These blue parts are the collection rooms. In the collection room, we maintain a constant and a rather low temperature at 20 plus minus 2 Celsius degree and 55 plus minus 5% relative humidity. This is to prevent the insect pests from developing and the molds from growing. In the collection room, we have wet collections and the dry collections. The wet collections were basically deposited in ethanol alcohol, and they evaporate, and the evaporation of alcohol may interfere the dry collection. This is why we separate the wet collection from the dry collections. This picture shows you the collection preserved in fluid. For the dry collection, we separate them into unidentified insect collection and a permanent insect collection. As the name indicates, the unidentified insect collections are those specimens that has not been identified to species. And once the specimen is identified to species level, we'll put them into a permanent collection. This is a picture of the unidentified insect collection, and here is a microscope slide cabinet, which has now been moved to the permanent insect collection room. This is an aluminum microscope slide tray that holds 20 slides, and we build a cabinet that can hold a total of 18,000 slides. This picture shows you the permanent insect collection. In total, we have 41 compactors, 984 cabinets, and over 7,000 drawers. All these metal cabinets were manufactured by BOT Limited in Germany. The order was received in May 1998 and completed in March 1999. The total cost for these cabinets was about $1.3 million US. This is our stable compactor. The purpose for setting compactors in our collection room is very simple. That is to make more rooms for our collection rather than aisles. As for the metal cabinet, it has a high-quality lock with an optional master key system. Each cabinet is tightly sealed and has 8 drawers in the cabinets. The advantage of these cabinets, in addition to others, is fireproof and waterproof. In addition, the drawer can be fully extended, and the drawer has a high load bearing capacity of 100 kilograms. In each drawer, we put a standard insect box, which is made of Formosan cypress, one of the highest grade of wood and the termite-resistant wood. The double groove on the edge of the box makes it airtight and pest-proof. Additional protection against insect pests and/or mold attack is provided by camphor powder filled in the wooden groove along the inner side of the box. Larger collections nowadays, for example, the Smithsonian Research, the Natural History Museum at London, usually use the unit tray system, which various sizes of unit trays was made to fit into an insect box. We use the Cornell University unit tray system. For example, a 4/1/4 unit tray can fit into the whole insect box. Likewise, the 16/1/16 unit trays can fit into this insect box. We have 4 different sizes of unit trays, namely 1/4 unit tray, 1/8 unit tray, 1/16 unit tray, and 1/22 unit tray. All these unit trays are standardized, and they are easy to replace. In addition, they are locally made and much cheaper if we buy it from foreign countries. Polyethylene foam sheets are used to pinning bottoms in unit trays. The high-density polyethylene foam offers chemical and physical stability, good for long-term storage, and may be pinned into repeatedly without showing pinholes. I would also like to spend some time to introduce you the labels. Our labels are acid-free labels. They have a standard size, and they are computer printed. As a tradition, on each label you will find where when, and who collect the specimen. Additional information can be found on the second or the third label. For example, you may put how you collect the insects or the whole species of the specimen. Barcoding is now used to manage masses of label data and retrieve information more efficiently. This picture shows you the barcode printer and the barcode scanner. At the Forest Arthropod collection of Taiwan, barcodes or the registered ID number of the specimen are often attached upside down so that a specimen can be picked up and read by the barcode scanner without moving or removing any other labels. Our barcode scanner can read DPI 200.3 barcode printed on a 12 by 9 mm label. The advantage of this barcoding system is that, first, it's a widely used and mature technology. Second, it's very convenient and can be read by machine or by naked eyes. It's fast, it's accurate, it saves labor, and costs down in terms of inventory and management. Today, there are more than 120,000 pinned specimens, including 200 type specimens with red labels housed in the Forest Arthropod collection of Taiwan. We have over 350,000 wet specimens. That means they were preserved in ethanol alcohol. Most of our specimens mainly came from field ecological studies, which is different from the traditional museum. We do not have enough taxonomy expertise, and what we did is to bridge the gap through international collaboration. For example, we invited famous taxonomists from abroad to help us identify our specimen to species level. As I mentioned, not only the material, but also the information of the specimens is very important. So the database which store the information of the specimens is very important for users. Our database was fully established by 2004. Information of each one of the 120,000 registered specimens can be accessed through internet, and this will be introduced later on. We joined the National Digital Archiving Program in 2005 and have produced over 60,000 high-resolution digital images since then. And this connection with our database added value of our database. For the past 18 years, we have built a modernized collection of insects, forest insects. In the future, we plan to expand our collection. We want to improve our quality, and we would like to provide better information and better management of our collection. Finally, I would like to thank to all who contributed to this wonderful arthropod collection. Without their help, this collection would be impossible. These are some of the tools we use to prepare our specimens. For example, this is the leg spreading block, which we spread the appendage or legs or antennae of the insects so that all the taxonomic characters can be exposed. This is so-called a wind spreading block, and this is a wind spreading block with a fixed groove. And this is a wind spreading block with adjustable groove, so that depends on the size of the butterfly or the moth, you can adjust the width of the groove. Again, the main purpose of this either spreading legs or spreading wings is to expose all the taxonomic characteristics for people to study. The main purpose of leg spreading or wing spreading is to spread all the appendages or the wings so that taxonomic characteristics can be exposed for study. In the past, our labels were not standardized and maybe handwritten. Now we use computer printed labels like this. And this is our barcode. For each specimen, we have a registered ID number, which is printed on this barcode. After leg spreading or wing spreading, the whole specimens will be put into oven for 6 days. This is our wet collection, or specimens preserved in ethanol alcohol. Traditionally, each specimen or several specimens are put into one vial. But you know, the ethanol alcohol evaporates, so you'll have to refill the alcohol from time to time. To save labor to refill the ethanol alcohol, we put all these vials in a big jar, and this, as the ethanol alcohol evaporates, we have only to fill one jar instead of many vials. All our dry specimens are kept in a constant low temperature and relative humidity. The temperature and the relative humidity is controlled automatically. We use this little machine to check manually to make sure that our temperature and relative humidity is under the desirable condition. The advantage of this compactor system is to save space. You will see most of the space in this room is allocated to compactors rather than aisles. And the compactor moves along the rails. The cabinets on the compactors are really heavy, but even a teenager can easily move the compactor. This is our cabinets. These cabinets are waterproof, fireproof, and lockable. Each cabinet contains 80 drawers. And the drawer is fully extensible and can hold a weight over 100 kilograms. Each drawer holds one single insect box that is made of Formosan cypress, the best wood in Taiwan and termite-resistant wood. There's a groove inside the box, so make the box airtight and pest-proof. We use Cornell University unit tray system to store our collection. This is 1/4 unit tray. This is 1/8 unit tray. This is 1/16 unit tray. 4 of this kinds of unit trays fit the whole insect box. Likewise, 8 of these unit trays fit the whole insect box. For each unit tray, there's a high-density polyethylene foam lined up the bottom of the unit tray. There are several labels beneath the specimen. The first label records the who, where, and when the specimen is collected. The second label may be some other information or the identification label. The last label in our collection is the barcode label.